lesson last week was about the interior angles of polygons, but this week we're going to be talking about the exterior angles of polygons. So let's start with an equilateral triangle. If I'm looking at the interior angles of this triangle, I know that each interior angle has to be 60 degrees. Okay, we talked about that last week, but now we're moving on to exterior angles. So let me go ahead and draw the exterior angles for each of these sides. If I just extend out the side of each of the triangle sides, I can get an exterior angle, which I'm drawing in blue. So all of these form a linear pair, and I know that a linear pair has to add up to 180 degrees. So if this interior angle is 60 degrees, what would the exterior angle be? Well, if they add up to 180, I could just do 180 minus 60, and that would tell me that each of these exterior angles would have to be 120 degrees. And since I have 3 exterior angles, 120 times 3 equals 360 degrees. So we just showed that all 3 of the exterior angles of a triangle add up to 360. Let's take a look at a square and see what happens with the exterior angles of a square. So for a square, we know that all of the interior angles of a square are 90 degrees. Okay, they all meet at right angles. And then if I wanted to start at each vertice and extend out the side, I could find the exterior angle. Well, since I have a linear pair at each exterior angle, I know that that exterior angle would also have to be 90 degrees as well, because they both add up to 180 degrees since they create a straight line. Alright, so now I have 4 exterior angles, and they're each 90 degrees. So if I multiply 90 times 4, I would get 360 again. So you could do this with each regular polygon, and you would discover that the sum of the exterior angles of polygons always equals 360 degrees. So that's a formula I like, that no matter what, all of the exterior angles of a polygon add up to 360 degrees. Alright, so let's take a look at an IXL question. The diagram shows a convex polygon. What is the sum of the exterior angle measures, one at each vertex of this polygon? So it sounds kind of wordy, but basically we're just wanting to find the sum of the exterior angles of this polygon. So you could draw out each side like we did in the example, or just use the rule that all of the angles, or the exterior angles, add up to 360 degrees. So no matter what, the sum of all the exterior angles is 360 degrees. So that is all you type in, 360. Okay, same question. What is the sum of the exterior angle measures, one at each vertex, of a convex heptagon? So once again, we're still wanting to find the sum of the exterior angles, but this time it's of a heptagon. Okay, remember a heptagon has 7 sides, but since we're finding a sum, it doesn't matter. They all add up to 360. So once again, the sum of all of the exterior angles would just be 360. Okay, so this question does not want the sum. It actually wants the measure of one exterior angle, which is labeled by x. So I know that if all three of these have to add up to 360, let me go ahead and draw the exterior angles on here. I'll just extend them in blue. So all three of these angles have to add up to 360. So if I want to figure out what one of them equals, I would just divide my 360 by 3. And that would tell me what each of these exterior angles equals. So 360 divided by 3 is 120 degrees. So the measure of x would be 120 degrees. So for these type of problems, you can use the rule 360 divided by n, and that would tell you the measure of each exterior angle. So we're not looking for the sum, we're actually finding the measure of just one exterior angle. 360 divided by n will tell you that, and n is the number of sides of the polygon. So let's look at another example. So this time I'm finding the value of x again. I just want to know what the measure of one of these exterior angles are. So I'm going to use my formula, 360 divided by n. Well, let's figure out how many sides this polygon has. 1, 2, 3, 4, 5, 6. So this is a hexagon, so my n equals 6. So I would just do 360 divided by 6, and that would tell me what this measure for this exterior angle would equal. So 360 divided by 6 is 60 degrees. So each of these exterior angles, if I were to extend them out, would be 60 degrees. Your passcode is Gong A Yong. Alright, now we get to step it up a little bit. We know that all of these exterior angles, which I'm going to draw for you here, have to add up to 360. So we're going to do a little bit of algebra. I know that all of these have to add up to 360. So let's go ahead and write an equation for that. V plus 34 plus 63 plus 135 has to equal 360 degrees. So if I simplify this, I would get V plus 232 equals 360. And then I just want to solve for V, because it's asking what's the value of V. So then I would need to subtract 232 from each side, which would leave me with V equals 128 degrees. Alright, then you could just go back in and plug that in up here if you wanted to check yourself and make sure that all of those exterior angles added up to 360 degrees. Alright, last problem. If an exterior angle of a regular polygon measures 60 degrees, how many sides does the polygon have? So we have to do a little bit of working backwards on this. I know that my formula, 360 divided by n, tells me what the measure of each exterior angle of a polygon equals. So in this case, I know that this formula has to equal 60 degrees because we know that each exterior angle is 60 degrees. So now I just need to use some algebra and figure out, well, what would n have to equal? So 360 divided by what number would give me 60 degrees? So in order to solve for n, I would just divide 360 divided by 60, which would give me 6. So this would have to be a 6-sided polygon, also known as a hexagon. Alright guys, if you have any questions, please let me know. Hope you have a great week. Talk to you soon.